Hi guys, these are the guided notes for solving quadratic equations by taking square roots. If you happen to have a printer and you're printing these off, quick side note, you will only need like the first 3 pages. There's a lot of extra stuff on this copy of the notes that we're using. They're old Algebra 1 notes. They go a lot further. We're just going to do the basics for what we'll need for this course. So basically just figuring out if you have an equation with a squared like this, what do you do to still solve for x? So one thing to note in the directions, it says, if necessary, leave answers in simple stratical form, which means unless there's some big numbers that I can't add, subtract, multiply, divide in my head, I'm not going to need a calculator because no matter what, we're not going to get a decimal, so I shouldn't have to worry about really unpleasant answers. So what I see is 3x squared minus 20 equals 7. Just like when you solved regular equations, linear equations, your goal is to get the variable on its own, but temporarily, we're just going to kind of pretend that this x squared is all one term. So what I mean by that, just kind of pretend it was 3y minus 20 equals 7. I mean, it's clearly not, but if it was 3y minus 20 equals 7, most of you would remember that the first thing we need to do to get the variable on its own is to add 20. Same thing over here. I'm going to add 20 to both sides of our equal sign, which means there's a 27 on the right-hand side of our equation, just like there would be on an equation like this. The 20s would cancel, and on this one I'd have a 3 and then y, but I'm kind of using this y as just the x squared chunk. So there's still a 3 there, there's still an x squared there. I'm going to not deal with the squared yet, because just like this example here, first thing I do is get rid of that 3. The opposite of multiplying by 3 is to divide by 3, and I would find that this y is 9. Now again, there's no y in this problem. I'm trying to get that thing on its own, so that thing is x squared. So I do still get 9, but I'm not done with this problem. I'm done with this guy, my made up, I'm just trying to get a handle of what's going on problem. For this one, I still have to get x by itself. So this is saying some number times itself gave me 9. Some number times itself gave me 9. A lot of us could figure out, well, that has to be 3. 3 times itself is 9. So we could say that x is 3. We've talked about before, but the opposite of squaring a number, the opposite of multiplying a number by itself, is square rooting that number. So we are solving by square roots. We are doing the opposite, the inverse of squaring, and that cancels it by square rooting. The thing is, there's another number that when you multiply it by itself, you get a 9. Specifically, there's another number multiplied by itself that gives you positive 9, and it's negative 3 times a negative 3. Because if you multiply two negatives, you still get a positive. So yes, 3 is an answer, but negative 3 is also an answer. So you get 2 solutions to this. Quadratic equations very frequently have 2 solutions. And one way to write this one is that we're getting a positive 3 and a negative 3. So really similar to regular equations where you get rid of the adding and subtracting usually first, then you divide or multiply usually next, but then we're going to solve by square roots. And when you solve by square roots, you're going to have to always remember that plus or minus, and guaranteed that is almost always the thing most people are going to forget. So let's do another one. Similar structure, so I'm going to do the minus 9 first. The opposite of subtracting 9 is to add 9, which yields 3x squared equals 9. Just like before, I'm not going to touch the squared right now. I need to get everything else away, and that's the timesing by 3. The opposite of multiplying by 3 is to divide by 3. Now I've gotten that term, that x squared term on its own. 9 divided by 3 gives me 3. So just like before, the opposite of squaring a number is to square root it. But unlike before, 3 is not a perfect square. There is no integer, no nice whole counting number that I could multiply by itself to give me 3. There's horrible decimal numbers, but like I mentioned before, I don't want horrible decimal numbers. So if you can't come up with a whole number for this, we're just going to do simplest radical form, which means since 3 is only made up of 3 and 1, meaning I don't have any pairs for these perfect squares, I'm just going to leave my answer as x equals square root 3. Because square root 3 times square root 3 is 3. Because root 3 times root 3 is root 9, and the square root of 9 is 3. But also, negative root 3 times negative root 3 is positive square root 9, which is still 3. Which means every time you solve by square roots, well, almost every time, you will be generating 2 solutions. Well, that was weird. Let's try that again. One more time. Whatever. There we go. So one last one here. Negative 4x squared equals negative 48. There's no plus or minus that we have to deal with here. So I'm just going to start by this negative 4. Now it's tempting to just add 4, but remember, when it's written right in front of the variable, it means multiplication. The opposite of multiplying is to divide. So that cancels it out. I've gotten my x squared term on its own. And here I have a negative divided by a negative. Just like when we multiplied, those terms are going to cancel, and I'm going to get a positive number. Specifically, I'm going to get positive 12. Also not a perfect square. So when I go to say, well, what's the opposite of squaring? And you say square rooting, that would give me a decimal if I pick up a lot of calculators. Instead, that cancels. Instead, we're going to find this answer by simplifying our radical, which means I'm going to come off to the side. I'm going to take 12 and ask myself, well, what divides into 12? One possible combination is 3 times 4. 3 is a prime number. 4 is composite, so it keeps breaking apart. So I'm going to get 2 and a 2. Which means the square root of 12 could be written as 2 times 2 times 3. And since pairs make perfect squares, well, sorry, I don't know what happened to that 3. Since pairs make perfect squares, when I have a pair of 2's inside my radical, I can bring a single 2 outside my radical, because 2 times 2 is 4. The square root of 4 is 3. The square root of 4 is 2. This 3, I was getting ready to say, is still just left over in the radical. Now, if I just say, oh, the answer is 2 square root 3, I'm going to miss some points, because every time you solve by square roots, you have to have the 2 solutions of both the positive and the negative, because we could show that negative 2 root 3 times negative 2 root 3 would still give us back that original 12. 2 negatives make a positive, 2 positives make a positive. Throw in your plus or minus. So we'll pick up the next example in the next video. See you then.